Hey everybody, my name is Andrew Baird and really appreciate your time joining my session today. In this session, we're going to talk about CICD best practices for modern applications. This is Dev 301. A little bit about myself. I'm a Principal Solutions Architect with AWS. I've been in this role for a little over 6 years, and I've been working with enterprise-sized customers in our Atlanta, Georgia office. And I've got a developer background, so helping companies get to modern architectures, embracing automation, using development tools and best practices has been a big passion of mine in this role. So I'm really happy and excited to talk to you about some of the great practices and some of the thoughts that we have around these paradigms and tools on AWS. So let's jump in. The agenda we're going to talk about today. First, I'm going to level set and talk about some common nomenclature, make sure we're on the same page about the way we define and talk about continuous integration, continuous delivery or deployment. We're going to talk about how those concepts apply to modern applications. Then I'm going to break apart the sections of CI and CD and talk about some specific services and capabilities that AWS offers to really enable best practices in each of those areas of the deployment lifecycle. And then I'm going to wrap up with a quick demo. All right, so let's jump in. Foundational topics within CI/CD. If you're familiar with the general CI/CD lifecycle, we like to break it apart into these four main components of the actions that are taken on your software as it's making it to production. So obviously it begins with code. These are the activities that your developers are hopefully performing, utilizing most of their time on day-to-day. They're writing code, they're getting it reviewed. And then once that code is ready to be checked in, a build phase occurs, and that code is built. And this is all of the activity that happens, hopefully through automation, against that code to locally test it and ensure it meets your quality bar, so that compilations succeed, unit tests occur, the code coverage is there, it's linted for any style constraints that you like to hold your code to, and we make sure that there's a built-in deployable artifact that's been tested and vetted by some local automation against that artifact to make sure it's ready for deployment. Then a test phase occurs, where that deployable artifact is going to be introduced into a real running environment, hopefully integrated with other components of software that other teams may own that you're integrating with. And you get a chance to test it again, test it against those dependencies it has. The dependencies that depend on your piece of software can ensure that your code is still meeting their expectations and requirements. And you do a slew of extra testing to make sure that that artifact in a running environment is behaving the way functionally and performance-wise the way you expect it. And then the final step is a deployment to production. And the real key to all of these things is to create feedback loops, right? That's what all of these segments are about, is about creating a feedback loop as quick as possible back to your developers so that bugs and defects and functional issues or operational issues are caught as quick as they can, as early as they can be in this process, so that fixes can occur and have them not impact your business or the running application for your users. AWS provides a slew of different services for each one of the segments of this SDLC and for those different components and points in time across the SDLC. So whether it's the code that's being stored, private Git repositories hosted by code commit, all the way through how your code's going to be instrumented and monitored once it's running in production through services like X-Ray and CloudWatch. So we have services to meet each one of the different phases that your software is going through in its CI/CD lifecycle. And if you want to get a good sense for how they all integrate with each other together, and you haven't used any of them before, or you'd like to start with a clean slate to give you a really packaged end-to-end working CI/CD pipeline, we have another service that wraps them up really neatly together in one place called CodeStar, where you can see them all integrated with each other and get a real working integrated pipeline working for your application from scratch. Okay, so now that we've got the baseline for how we think about the different phases within the SDLC, let's talk about modern applications. So modern applications, the tenets that they strive for aren't really any different from past moments in software development history. It's all about delivering high-quality software that is meeting the needs of your business. You strive for operational simplicity. You want to embrace automation everywhere you can. And you want to be able to have an application that's well understood operationally so you know exactly how it's behaving. But the difference for how this is implemented in a modern way is the mechanisms with which you have to achieve those tenets have gone up many fold in the last few years. We have CI/CD tooling to enable how fast software can be delivered and how iterable you're able to think about how small those changes can be. Different ways that software is deployed with managed services and serverless architectures, microservices patterns, security being able to really be pushed all the way down into your development processes so that developers are the ones who are baking security into their applications. So there's just been a lot of technology shifts that have happened that pushed all of the ability to deliver high quality software in a modern application closer and closer to developers. And in this session, we're really just going to focus on the CI/CD elements and how that's enabled your developers to achieve using all the rest of the technologies in the list with faster speed, able to deliver incremental changes to your applications even faster, and have those feedback loops close back to your developers even quicker, so that problems can be rectified and resolved, hopefully before they've even made it to production. And just to give you an idea of that sense of speed that you're able to achieve, the agility that you're able to pursue as a result of embracing CI/CD, these are some numbers that were published by DORA, the DevOps Research and Assessment Group, on kind of the difference that you're able to see in the real change velocity and the failure rates for development teams that are embracing CI/CD versus those that are not. And it's really drastic. You go from deployment frequency that is weekly or monthly to hourly or daily. And think about the competitive differentiation that can give you, both to outstretch your competitors, but also to react quickly to your users and what they're telling you about what they like or they don't like about the experience they're having. So that lead time goes down really, really low. The change lead time, different than deployment frequency, is how long does it take for a change that I've contributed to make it out to production. So getting that lead time down from an order of months from when I've written code to my users are interacting with it down to days where it's in their hands, the business is getting the benefit of the time I've put into development, or I'm able to close the feedback loop and not lose context on the changes that I've made and the failures that might be occurring as a result, so I can fix them without having lost context over a really long period of time. And because those changes are smaller, you get really nice and well-reduced failure rates too. Those feedback loops are closing continuously earlier on in the development cycle, so that the amount of failures that do occur are smaller, both in terms of impact as well as volume. So you get a ton of benefits just by pursuing CI/CD. It's really, of all the modern things you could be doing in an application architecture, implementing automation for your deployment and all of those different stages is really the best place to start. And a really unique point in history, I think, that just to kind of really emphasize this, is we're at a unique point in history, I think, where there's still only 48% of teams that are really achieving these numbers, right? Not even in the majority yet as of 2018. I'm sure that number shifted over the past 2 years, but still probably not by much. And CI/CD and all the tooling available has gotten a lot of maturity over the past few years as well. There's tons of best practices out there you could be following, and a lot of tools you could be taking advantage of on places like AWS. And be learning from those that have done it before you and getting all these benefits. So we're at this nice inflection point where there's a lot of maturity in this space, but still not even the majority of teams that are taking advantage of it. So it's a really nice place to be where there's a lot of impact that can be felt still. All right, so now let's talk about specifically the different phases of CI and CD and some of the capabilities within AWS that help address the benefits and the actions that happen within them. Okay, so continuous integration. Implementing continuous integration refers to the ability of having source code changes that are checked into code repositories be automatically picked up and built. So the idea that code is checked in by a developer, it's introduced into a shared repository where all the other developers' code, who's hopefully behaving nicely and has met all your quality bars, is now going to be introduced into that mainline build or release branch, what have you, and is going to be built and unit tested and made sure that it's met the bar. So it hasn't been deployed yet. We're just making sure that the code that's been written can be integrated into the larger set of shared code that the team has written. So just to really spell it out, these are the same steps I just described, but the main thing that I really want to emphasize is that immediacy of the feedback loop with continuous integration. As soon as somebody's checked in, if it's automatically going to be picked up and a unit test fails, or the quality bar for code test coverage hasn't been met, or there's style issues with the way that particular developer has written the code. Usually a build is something that can happen within the order of minutes, for really massive or monolithic application. Maybe it takes longer than that, but certainly in the order of hours at even the stretch sizes for some teams before that feedback loop is closed, but usually in the order of minutes. So any developer that's contributed a code change that's resulting in a build that's not succeeding, or code test coverage that is slipping lower than you want that bar to be set at, that developer is almost immediately notified that there's an issue and they can get back to work on fixing whatever the result could be. So I did want to emphasize that in this case, for continuous integration, that feedback loop closes so quickly that the benefits are extremely important. You don't have those cases where a developer is checked in code, and it could be a day or more before they're notified, and there's other developers who are blocked with a build that's broken that they're not able to contribute to or test out in a test environment. They're able to be notified immediately that something they just contributed to has an error in it. And CodePipeline is the service on AWS that plays the role in automating how those code changes are picked up. So it's a continuous delivery service, and we're going to talk more about continuous delivery later, but in order to even achieve continuous integration, there needs to be a service that is responsible for automatically picking up things and pushing them through whatever your CI or CD pipeline are going to achieve. So CodePipeline is that CD service that's going to kick off your continuous integration step. So it gives you a place to model all of the changes that are going to occur, hook into the various services that are going to literally perform the builds or the tests within your environment. And then we'll talk more later about how it integrates with other things that exist further down on the pipeline to perform the real deployments and things like that. So the way that your continuous integration steps can be triggered, CodePipeline can integrate with a variety of different sources. So they can either be code-centric sources like code commit or GitHub. This is the literal repository where your code is stored. Or if you have your code stored in a different type of repository that's not Git-centric, or you're working with a type of application artifact or existing build processes or code processes that don't hook in neatly with those two, you can use an S3 model of integrating with code commit, where every time you've packaged up some code artifacts or a deployable unit and you want to upload it to S3, that can be treated as the initial trigger for CodePipeline to kick off a pipeline execution as well. You've got both of those choices. So depending on the choice you choose, you can either pick a branch within code commit or GitHub. You choose a specific object location in S3. And then the third option you have for triggering a CodePipeline deployment is Docker-centric. So if you've got a containerized application, you take that container image and you push it to a specific tag for that image to our Elastic Container Registry service. Every time a new image gets pushed with that tag, CodePipeline will recognize that and trigger a build as well. So you've got these three different types of options today for kicking off new builds or new integrations or delivery pipelines with CodePipeline. Okay, so just to really help visualize for the containerized, because that's a demo I'm going to do later, you have a particular source code branch called master. You've got a tag that's called out for ECR that's called your release tag. So either one of those two could be viable. Say you're deploying a new container. It's going to be running in our ECS service, just like my demo. So you define either one of those, and if a code change happens to my master code branch, or if I had chosen to build my image locally, maybe you want your developers to build and test locally on Docker with their laptops, and they'll push a new release tagged image into ECR, and that will trigger CodePipeline to pick it up and push it to a build stage. And then, assuming the build succeeds, another step will be defined in CodePipeline to deploy your ECR image, your Docker image, to ECS. Now, other than ECS, that's what I'll be demoing later. You've got a couple different options for how that deployment's going to occur too. You can deploy EC2-centric applications on servers. You can deploy container-based applications on ECS, Fargate, and it works with serverless applications using Lambda as well. So you have a slew of different automatically supported, natively supported application architecture models, deployment models that integrate with CodePipeline natively. Aside from thinking about the change triggering a CodePipeline execution from occurring, you can also think with other ways as well. So if you, for whatever reason, you want a time-based integration pipeline to be kicked off, you're not quite ready for every change to be picked up automatically, you can use CloudWatch events to trigger a CodePipeline as well, maybe on a schedule, maybe on certain health events. So if there's a degraded instance within your environment that you want to trigger a new build on, or if a new deprecation notice comes for a particular service that you're utilizing, like Fargate, or for retiring a platform version, you can utilize CloudWatch events to trigger those. Or you can use webhooks. So webhooks for a variety of third parties can support triggering CodePipeline executions as well. So next I'm going to focus on specifically the types of modern architecture models on AWS that play well with these code pipeline, these CICD native services, and what the specific integrations look like with CodePipeline in order to leverage either serverless or microservice-based architecture. So the services I'm speaking about are Lambda and Fargate. So both are serverless in nature, reduce the management complexity you have. One is function-based, where you're writing very minimal business logic-only code that is going to be deployed as functional units, functions on top of AWS Lambda. Or on the other hand, Fargate, where you're going to be deploying container-based applications, but the infrastructure is still fully serverless and managed by the service. So two different options, both great approaches. We're not going to get into how to choose between one or the other in this session. There's lots of opinions you can read on the matter and which is a better fit. For others, we have some high-level details listed here for some ways you can think about the different types of services, but both are great options depending on your preference to deploy modern applications. And now I'm going to talk about kind of the model for integrating with our CI/CD services for both of those. And the service where it's going to really start getting specific, because CodePipeline is just code. Whether your code is destined for a container image or a Lambda function, it's still code in the end our developer's written. If you're hooking into a Git repository, the CodePipeline is going to be triggered in the same way as that code is checked in. So it's really code build in the build step where you start seeing a divergence in the paths for how you're interacting with either functions or containers. So CodeBuild is the service that plays that automatic build role within your CI/CD pipeline on AWS. It's a fully managed build service. It provides you build images that are able to be deployed on demand as changes occur. You only pay for what you use, so you don't have to have continuously available build servers anymore that you're paying for and maintaining and managing. When a change needs to be built, that build environment is stood up for you. You only pay during the execution of that build, and then it spins down when it's no longer needed. You can have those builds occur triggered based on CodePipeline executions like we've talked about, but they can also be triggered within specific hooks themselves, where if you want just the build to occur outside of a CodePipeline execution every time a new commit is occurring against your repository, that can happen as well. And the important thing to emphasize here is that every one of those builds is going to run in a completely isolated, brand new Docker container environment, so you don't have to worry about that environment changing from one build to the next. Any activities that happen as a result during that build, like tests that have occurred or data that's needing to be manipulated within the environment during that test, you start with a brand new, fresh image every time that build occurs, every time a new build occurs, so that you can have a lot of faith and consistency in the builds that happen across all of your different development changes. So say you were building a Lambda function. This is an example of what is called a build spec file. So that's the way that CodeBuild as a service is instructed how builds occur for your application. So this looks like a JavaScript Lambda function. We've got a couple different commands that are going to run in the underlying build environment. It looks like a Linux environment that's going to run a couple npm commands to check our code and to run the tests that I've configured in my code package. And then it's going to use CloudFormation and its package functionality to take the Lambda function code that I've got stored alongside this build spec file and package it all up together and upload it to S3 as a zip artifact. So don't think too deeply. There's tons of documentation on how these build spec files occur, but just know that this is a file. It's a YAML file that lives alongside your source code. And when you perform that check-in, this build spec file is going to inform the CodeBuild service on what commands need to be executed in order for the build to occur for that application component. Okay. If you're working with a containerized application, a Docker-based one, this is an example of what a build spec file is going to look like. So for example, here we're going to interact with our ECR service to get some credentials for the Docker registry. So a boilerplate command there that's run to get us temporary Docker credentials. And then a couple Docker-centric commands to build a new image, to tag that image, and to push it into to ECR. So Docker-centric commands, but again, it's just a simple file that lives alongside your source code, and it informs the build environment, the types of commands that need to be executed as part of a build for your application, nothing more than that. Okay, so just to recap, continuous integration goals. Every time code changes occur, new code is checked in. It's going to be automatically picked up, introduced into the shared code repository, and kick off a new build. Now let's talk about continuous deployment. So what to do with those, ready to be deployed, built artifacts, and how to introduce them into an environment. So continuous deployment for us is about automatically deploying changes as they're checked in through all of the build and test cycles all the way through to production. Continuous delivery, for those that want to practice it, is usually stopping at a lower lifecycle environment, a dev environment, QA, not all the way to deployment, but very similar tenets involved, but just the ability to have confidence in your testing, the amount of test sophistication that you have to be confident to go all the way to production. That's the big difference for continuous deployment. So you want to automatically deploy changes to all test environments, trigger performance tests, unit tests, integration tests, all of those things. And once you're happy with all of those things, you can deploy them to production. And those feedback loops are important. And obviously, if you're going to deploy changes automatically to production, it's really important that you have a feedback loop quickly if any deployment failures occur, and you perform a rollback and not impact your customers too. So just because you have continuous deployment doesn't mean that there's not a capability to pull those changes out and roll back automatically if anything has gone wrong. So the service from AWS that's going to play a role there is called Code Deploy, and it automates code to any type of instance, any environment, and to AWS Lambda. And that doesn't just mean AWS environments, any VM-based environment that can run the Code Deploy agent, whether it's on your on-premises environment or elsewhere. The Code Deploy service can automate deployments to it. And it handles the complexity of what has to happen in that infrastructure environment when a deployment occurs. What does a deployment mean? And it gives you a slew of different hooks and automation for the types of deployments that occur. We're going to talk about blue-green deployments in a minute, but it has other options for rolling deployments, all-at-once deployments, and all sorts of things to detect rollback and perform automation to make sure that your deployments go smoothly. Similar to the build spec file with the CodeBuild service that I described a second ago, Code Deploy has another file. It's called the app spec file. So this is going to be an EC2-based deployment. It looks like we've got a Linux environment. We've got VMs that are running a particular application. And this app spec file is going to define the actions that occur on a particular VM when a deployment is triggered. So the Code Deploy service is going to inform a particular VM that a deployment's been triggered, and this app spec file is going to inform that VM of all the steps that need to occur on itself in order for the deployment action to take place. So it looks like we're copying some particular web app files from one directory to another. We're going to set permissions on those files appropriately, so the way that our application expects it. And then finally, we're going to run a slew of different deployment scripts that occur. So it looks like we're going to deregister the instance from the load balancer so it stops accepting requests. We're going to run a kind of a deployment and web server start set of scripts. And then once those things are done, we're going to run another script to locally test our site on the instance and then register it back with the load balancer. So all of those hooks is just an order of execution steps of things that you want to, shell commands or scripts that you want to execute within the deployment host that create a deployment action for you. Okay, nothing more than that. So this is an app spec file, and it also lives alongside your source code, just like the build spec file does. And when a deployment occurs in Code Deploy, this app spec file defines what's going to happen. The way that the deployments are targeted, you've got, again, like I mentioned, a couple different options for how quickly the deployment will roll across your infrastructure. One at a time, half at a time, you can define that percentage, or if it's just going to be an all-at-once deployment. And then for targeting which bits of infrastructure that deployment needs to occur to, where does this software change need to be deployed to, you create what's called a deployment group. So depending on how you've organized your infrastructure, different VPCs, or it could be different subnets, or it could be different AWS accounts altogether, those Code Deploy agents that are running on your running infrastructure are going to define a collective set of infrastructure that's going to be deployed to. For Lambda-based deployments, we're going to have another app spec file, but all it's going to do is inform the Code Deploy service that this is a serverless application running on functions, an optional parameter for what type of deployment I want to execute with my Lambda function, and some more hooks around monitoring the success of that deployment, as well as where testing and automation can occur before and after the deployment. So I'll go back a slide for a second. If you saw the preference here, a Canary deployment, that's going to do 10% for 10 minutes. So what that means is that I've got a running function version, v1. I'm going to perform a Canary deployment against v2. So I've got a second version of my code here, and we're able to hit a hook using the code deploy service that before any live traffic is cut over to my V2, I'm able to run tests against that V2 version. And once I'm happy with that test having been executed and it's been successful, 10% of traffic is going to be shifted over to V2. And once V2 has been running for 10 minutes with 10% of the traffic, and an alarm hasn't been triggered, the rest of the 100% of traffic will automatically be shifted over to V2. So now that all of my traffic is being served by V2 of my Lambda function. Code deploy also supports containerized applications, so blue-green deployments with ECS. So here's an example of what the app spec file looks like for ECS. Defines where my task definition is, so that's, the container images are inside that task definition and some resource information about those container images. The load balancer associated with my deployment, and again, a list of hooks that represent Lambda functions in reality. And these are Lambda functions that are going to be executed in sequence in each of those deployment steps to let me run some Lambda-based automation to ensure my deployment is successful and tested and validated. So let's visualize what this really looks like. I've got a web application with traffic being served by an application load balancer. I've got a listener and a target group running against my blue tasks, we'll call them, in target group 1 running on port 80. So the way these blue-green deployments work is I set up a second listener on my load balancer with a different port. So here I've got a test listener running on port 9000 and a second target group that receives traffic from that test listener. So during a green task deployment, we're going to deploy and run those green tasks, but all of my prod traffic is still hitting 100% the blue tasks. As those hooks run, it's going to give my automation through Lambda a chance to hit those green tasks even before any of the production traffic has been shifted. So anytime I hit that test port 9000 in my case, I can have all of my test suites configured to hit port 9000, and that ensures that they're always going to run against the newly deployed test set of tasks. And all of the tests will go there, and all of the traffic is still running on the already deployed blue tasks. Once I'm happy with those tests that have been run, we're going to flip the production listener to now point at target group 2, so that all of my production traffic now is hitting those green tasks. And those blue tasks are still up and running, but they're not receiving any production traffic. And you can define how long is that blue set of tasks going to run with connections draining, and have them kept around to ensure that no alarms are breached, everything is still successfully running with the green tasks. And once you're happy with everything running, you're able to fully switch over, and everything is going to be running on the green tasks. Okay, so a quick demo here. I've got a particular website, and if you go to mythicalmisfits.com, we have a workshop that's going to run you through building this application yourself too, and I've modified the workshop to enable blue-green deployment. So I've got it running and deployed already, and there's a couple issues that are preventing my misfits from running. So you can see on the original version, there's a slew of misfits that I can sort and filter based on certain qualities they have, and for some reason, they're not able to load on my version of the deployed website. I just checked a code change in, so it was probably automatically deployed, and the green version of my tasks are unhealthy in my blue-green deployment. So let's take a quick look. I have a code pipeline execution here, and it looks like it's already automatically caught those failures that looks like 20 minutes ago when I was doing some testing. So let's refresh here. So we've got a new deployment that's occurred in CodePipeline, and it's run through the build. And this is going to describe all of the changes that have occurred. And when I go into code deploy, you can see the past deployments that have occurred. So if I refresh this page, you'll see once it loads, a couple failed deployments, and it looks like it's just failed recently. And the reasons for its failure is because there was an invalid parameter exception. So all of these deployments that tried to occur, even before I could get the demo up and show it to you, those errors that I was inducing on my site were automatically caught by code deploy. If I go to the alarm that's being viewed by code deploy and I refresh this page, you'll probably see some past errors. So it looks like a particular error threshold was breached and that rollback was triggered. But just to kind of give you a view under the covers a little bit more on code deploy. So what I have here in code deploy, I have an application created, and I've pointed to a particular ECS service where that application deployment is going to occur. this particular cluster, this particular service. So anytime that CodePipeline deployment triggers a deployment within this application, it's going to trigger a deployment against this ECS service. If I scroll down to the particular deployment configuration, or scroll down a little bit further, you can see that I have an alarm configured here, so that anytime this CloudWatch alarm is going to get breached during a deployment, it's going to automatically disable the deployment and perform a rollback. So it's in Code Deploy where you're able to define, what service is being deployed to, what's the rate with which deployments are occurring, and then you're going to be able to configure how to deployments automatically catch that a failure's occurred and a rollback's been performed. So those are all the pieces working together. I'm going to jump back into the presentation and just give you a quick summary. So again, just a reminder here, continuous deployment is about automatically picking up those changes and having them be deployed into the running environment, not impacting customers, changes that are found to be causing errors or issues or causing alarms to be triggered, recognizing that and automatically performing a rollback and getting those feedback loops created both in your software so that changes can happen automatically, but back to your developers so that deployments can be made more successfully, more frequently. And that's the summary of continuous deployment. So if you want to dive in more, we have a ton of other resources available, all available on our website and at the URL listed on the bottom here that will help you build modern applications following these modern methodologies and services that I've laid out here. And please do look into our certification programs as well, which have a ton of knowledge and best practices you can pursue and get certified in that will test your knowledge as it relates to these concepts like CI and CD. And I thank you very much. That's the end of the session. And again, I hope you're enjoying the virtual summit. It's been a pleasure presenting to you. And thank you again.